All right, let's talk about section 5.3. This one's actually a fairly short one. It's talking about graphing some radical functions. Now, the two most common ones you do are square root and cube root. And actually, the other ones look very similar to these. Like any even roots look very similar to a square root. Any odd roots look very similar to a cube root. So a square root graph looks like the half of a horizontal parabola. Like this one, the positive one looks like the top half of a horizontal parabola. Notice for it, it's going to have a certain domain and range because there's only so many numbers you can plug in for x because you're doing an even root. So there's only so many answers you'll get for y. So it'll have a domain and range. Now the cube root function, its domain is almost always all real numbers and the range is almost all real numbers. But that's what the parent functions look like. Now, after you have the parent functions, like let's go ahead and graph a couple of these. Like here, the square root of x, just to see why it looks like that. If we plug in some numbers for x, and since it's the square root, you want to plug in some numbers you know the square root of. Like if we use 0, well, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. 9 is kind of off our scale, but if we went, the square root of 9 is 3. Now, we couldn't plug in any negative numbers because we can't do the square root of a negative number. So that's what a square root graph looks like. Again, it's the top half of a sideways parabola. The cube root graph, now we can, since it's an odd root, we can substitute in positive and negatives. We put in 0. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. If we plug in some negative numbers, the cube root of a negative 1 is negative 1. And the cube root of a negative 8 is negative 2. So that's how the cube root graph gets its shape. Okay, so that's where those come from. Domain and range. Well, here, like for the square root graph, you can see the domain. If we look at our graph, remember domain is left to right. Well, the farthest left this goes is 0. The farthest right is it goes to infinity. So here the domain would be, so x is greater than or equal to 0 and less than infinity. The range, notice there's no negative numbers, so the range, y is greater than or equal to 0 and less than infinity. Now for this one, like we mentioned on the cube root graph, the domain is all real numbers. So we can say all real numbers, or we can put it like this. X is greater than negative infinity and less than positive infinity. The range would be the same thing. So all real numbers. Now, if we're moving the graphs around, it works just like we've done before with the quadratics and stuff. We have a horizontal translation. If there's some in with the x, and that's x minus h, that tells us that we shift left to right. And you always think opposite because it's x minus h. So if it's x minus 2, that means h is 2, so that's right 2. If it's x plus 3, that means h is negative 3, so that's left 3. So we just shift the graph that way. If there's a number on the outside, remember that's the k we used before, plus k, that's a vertical translation. That's just like it looks, except it's up and down. So if it's this, radical x, and then there's on the outside there's a plus 7, that's up 7. If on the outside there's a minus 1, that's down 1. Then if there's negatives in there, if the inside has a negative x, remember anything on the inside is horizontal, so that's flipped horizontal, so it's reflected in the y-axis, so it's flipped sideways. You just change all of the y coordinates, you change their signs. If there's a negative, change the sign of all the x coordinates, Negatives in with the x. I was thinking to the next one. Now notice if there's a negative on the outside, again, anything on the outside has to do with y, that's reflected vertically. So it's reflected in the x-axis. So you change the sign of all the y coordinates. So it's inverted. Then, now these next ones, they don't happen very often, is if there's a number multiplied in with the x, like here a 3x, we always, when it's in with the x, we always think kind of opposite. So when there's a 3 in there, that's actually shrunk by a factor of 1/3. So that's shrunk horizontally. You would take every x coordinate times 1/3 to get your new point. So even though that's a 3, we think the reciprocal of that. If there's a fraction in there like 1/2, that's stretched horizontally by a factor of 2. Again, we think of the reciprocal, kind of not really the opposite, but the same general idea. So there you'd multiply each x coordinate by 2. So it's kind of backwards of what you would think. Now, if the number's on the outside, then it's a vertical stretch or shrunk, and then it's exactly like it looks. Like if there's a 4 on the outside, that's stretched vertically by 4. So you take every y coordinate and multiply it by 4 to get your new points. If there's a fraction outside, like a 1/5, that's shrunk by a factor of 1/5. So anything outside that's between -1 and 1 is shrunk. So that's shrunk vertically. You take every y coordinate and multiply by 1/5. So if we go do one of those, like this one here, well, that's a square root graph. We already did one of those, so we know what it looks like. Well, if we look at that, there's a -3 inside. That means right 3. There's a 4 on the outside. That means up 4. So we're going to take that graph we did up here, and we're going to do those two things, move it right 3 and up 4. So we had a point at 0, 0, so we go right 1, 2, 3, and up 1, 2, 3, 4. There's a point here at 1, 1, so from there we go right 3, 1, 2, 3, and up 1, 2, 3, 4. Or this point here at 4, 2, we go right 1, 2, 3, and up 1, 2, 3, 4. So that graph looks like this. If you're not sure, you can always plug some numbers in for x. So now for the domain and range, well, the domain, what it looks like now, our x is the farthest left they go is 3, and then it goes way to the right. So we put 3 is less than or equal to x is less than infinity. So x is greater than or equal to 3 and less than infinity. The range is up and down. Well, the farthest down it goes to 4. So y is greater than or equal to 4 and less than infinity. Okay. Now this next one is a cube root graph. So here's our parent function. So we're going to shift that graph. Now it has 3 things going on. It's got a 2 out front. That means it's stretched vertically by 2. So we're going to multiply every y coordinate times 2. It's got a negative, so it's inverted. I use the term inverted. The book will say reflected in the x-axis. Same thing. And then on the outside, it's got a +1, so that's up 1. So we're going to do those 3 things. We're going to multiply every y coordinate by 2. We're going to flip it across the x-axis and then move it up 1. So here we had a point at 0, 0. Well, if we stretch it vertically by 2, well, 0 times 2 is 0. Inverted, well, if it's right on the x-axis, you invert it, stays on the x-axis, and then up 1. So that point's just going to move to right there. This point that was at 1, 1. So we're at 1, 1, stretched vertically by 2, so we take the y coordinate times 2. 1 times 2 is 2. Inverted, it moves that to a -2, and then up 1 from there. So there's our 3 things. We were here at y equals 1. We stretch it vertically by 2. 1 times 2 moves us up to 2. Inverted puts us at a -2, and then up 1 puts us at -1. Or this point that's out here at 8, 2. So we're out here at 8, 2, stretched vertically. We take 2 times 2 is 4. Inverted puts it at a -4, and then up 1 from there. Or this point over here at -1, -1. So we start at -1, stretch vertically by 2. -1 times 2 is -2. Inverted moves it to a +2, and then up 1 from there. The last one with this one, -8, -2. We're at -2, stretched vertically by 2. -2 times 2 is a -4. Inverted moves it to a positive 4, and then up 1 from there. So there's our graph. Now again, if you look at the domain, well, it goes way left and way right. So our domain is all real numbers, so negative infinity to infinity. Vertically, it keeps going down and keeps going up. So the range is also all real numbers. Okay. Now the last thing on here is writing equation for these. This can get kind of tricky. You have to be really careful about this. So like this one, we have a graph of f of x. Here's the original graph. The original graph is the cube root of x minus 1. Now it says we want to vertical shrink by a factor of 1/6. We want to move it left 3. Now this one is better than some, because if this is a vertical shrink and this is moving left, well, that's horizontal, that's vertical. Those don't really affect one another, which is good. So if we take that graph, so we're going to make g of x. So we can do these in any order. If we're going to move it 3 to the left, well, inside here, in that cube root, 3 to the left means x plus 3. Remember, we always think opposite. So that told us 3 to the left. Then and then we still have the minus 1 out front. So we adjusted, that's shifting the whole thing left 3. Now we're going to shrink it vertically, so that means we need to put a 1/6 on the outside. So that looks like that. So it could have been harder if this had been vertical along with this one, then it would have got tricky. But here, so we moved it left 3, so inside with the x, we put a plus 3 for left 3, left everything else alone in there, and then vertical shrink by 1/6. Vertical is on the outside, so we put a 1/6. That's why we had to put all that in parentheses. And if you're not sure, graph what you have and see if it looks like it fits the criteria. Okay? And that's all there is to 5.3.